So, greetings once again, my students of physics. This was where we stopped at in the first video of this simple harmonic motion series. Now, we are going to continue from here and make a list of all the formulas we are using for the topic. Okay? Now, we continue from number 7. Of course, now you can see that we have this angular velocity has 5 formulas. 1, 2, 3, 4, and 5. All right. Then number 7. Sorry, before we continue, if you have not subscribed, you can help us to click on that subscribe button there. Yes, and then turn on notifications so that when we post the next video, you will be notified. Now, we continue. Now, we're going to look at this. V is linear velocity. If you check, that's what you have in your table there. The formula is this. We use WR, okay, or V is WL, or V is WA. So you can use R, you can use L, you can use A. What is R? I gave you radius. L is length. A is what? Area. Is it clear? So these 3 formulas can give you linear velocity. Then we now have number 8, alpha. If you check what I gave you there in the table, alpha stands for angular acceleration. And you want to solve for alpha, it is W2 minus W1 over T. W2 is higher angular velocity. W1 is lower angular velocity over time. Then if you now go to the next one, A is linear acceleration. The formula is alpha R, or you can use A is alpha L, or A is alpha A. It's just like this one. Are we good? So that's what we have. Now, we will continue. So you make a copy of all of them. Now the next one is the formula for simple pendulum. I believe you have heard of simple pendulum before. So the formula for simple pendulum is, so for a simple pendulum, I'll give you 2 formulas. We have T is equal to 2 pi root L over G, or T1 squared over T2 squared is equal to L1 over L2. Take note, these 2 formulas are formulas for a simple pendulum. Once a question talks about simple pendulum, you remember this formula. When we're going to do some calculations to this effect so that you can digest the information. Okay. Now, number 10. Let's talk about formula for centripetal force. I'll be discussing the theories in the next video. So centripetal force is equal to mv squared over r. Centripetal force is equal to mv squared over r. Then we have we have centripetal acceleration. Centripetal acceleration is equal to v squared over r. So take note of that. And you know, you can also call this to be, you can say m v squared over l. Yes, you can say that because r and length are the same thing. Then you can also say mv squared over what? Over A. Okay, so please, R is equal to L and is equal to A. Take note of that. Now, we move ahead. The next formula we're going to look at is formula for velocity of simple harmonic motion. Velocity can interchangeably be used as speed, though they are not the same thing entirely. In quantity, they are the same thing, but in speed, in by direction, they are not the same thing. So, but you can interchangeably use them. Velocity and speed, you can interchangeably use them. Now, the formula is omega square root of a squared minus s squared. Take note of this. I will be explaining how to use them in our calculation section of this video. Then, acceleration of simple harmonic motion is negative omega squared x. Sorry, in the table, I didn't give you the meaning of x, so I will write it down so that you will add it to your table. I didn't give you the I do a live video, so I didn't give you the meaning of this x. So let me write it for you. So add it to your table of quantities, symbols, and units. So x stands for perpendicular distance. Perpendicular distance from center. So please add it to that table I gave you in video 1. The unit is meter. In the unit side, write meter. The unit is meter, okay? Now let's quickly finish up the formulas. So we'll start at formula 13. Now formula 14 is at the center. Once you hear center, know that x is equal to 0. Center can be said to be middle. So at the center or middle, x is equal to 0. Now, when you hear at the extreme, x will be equal to a. Remember that a is amplitude. So at the center, at the extreme, I'm going to bring you back to this much later when we start our calculations. Then number 6, PE. P is potential energy, max is maximum. So PE maximum is always the same thing as KE maximum. K is kinetic energy, maximum. This is maximum. This is maximum kinetic energy, maximum potential energy, and is equal to total energy. Are you with me? But all of them now, all of these 3 now, we have a formula that can solve for 3 of them, and the formula is we can use half KA squared, or you can use mg h max. Now h max means maximum height. Please take it down, add it to your table of symbols. H max is maximum height. Then we will add 2 more formulas and then call it a day for this particular video. Now 17, maximum velocity. So you can be asked to solve for maximum velocity. Okay, maximum velocity is WA. Take note, or you can even call it WL, or you can call it WR, depending on what you are given to use. Then finally, maximum acceleration. This is maximum acceleration. The formula is negative omega squared A, negative omega squared A, or you can say negative omega squared X, or you can say, sorry, omega squared L, or you can say negative omega squared R. Take note of that. So this is a compilation of formulas we use in studying simple harmonic motion. So make a copy of all of them, get familiarized with the symbols and everything and the formulas. Then in the next video, we'll now do an explanation of the topic and then start solving calculations. Like I said, this page is all about we'll solve calculations, but I'm going to do a theory on the topic, a little bit of an explanation. Then we'll now start the solving. So in the next video, we do the description of the topic and then we'll start the calculations. Okay. So thank you very much, and then see you in the third video of the series.